Welcome to part 2 on the unit circle. We're going to show that root 2 over 2 as a coordinate point is on the unit circle. We can do this by using the equation of the unit circle, which is x squared plus y squared equals 1. All we have to do is show that when we replace x and y with the values in the coordinate point, we get a true statement. So if we replace x with root 2 over 2 and we square it, and we replace y with root 2 over 2 and we square it, we should hope that it will equal 1. This will give me 2 over 4, simplifying the first term, plus 2 over 4 equals 1. And this is indeed a true statement, and so we have proved or shown that the coordinate point root 2 over 2, root 2 over 2 does actually fall on this unit circle. If we wanted to take the point x negative 1/2 and we wanted to say that it is on the unit circle in quadrant 3, that's very important, then we need to find its x coordinate. So we can take again the unit circle equation, x squared plus y squared equals 1. We can substitute negative 1/2 in for y. And we can force it to equal 1. Therefore, we can solve for x and figure out what it would need to be. So if I know that x squared is plus 1/4 is equal to 1, then x squared is equal to 3/4. That's just subtracting the 1/4 from both sides. And so now I can take the square root of both sides, and that gives me x is equal to plus or minus the square root of 3 over 2. Now the last step here is to actually draw the circle and see what we're dealing with. Then I know that I'm in the third quadrant, and so in the third quadrant, x and y are both negative. I'm telling you this because if I know that I solve for x and it's root 3 over 2, that doesn't necessarily make sense. Notice that we're squaring both of these. We're squaring the x and we're squaring the y. So if I want something in the third quadrant, my x needs to be negative and my y needs to be negative. That means that I will have negative root 3 over 2 and negative 1/2. So this is approximately where my point on the circle is. And the question is, does it make sense? Does negative root 3 over 2, comma, negative 1/2 actually work in the formula? Well, let's check it just to be doubly sure it works. I can take the negative root 3 over 2 and square it, plus the negative 1/2 and square it, and we can check to see if that equals 1. That will give me 3 over 4 plus 1 over 4, and that does indeed equal 1. And so we have found a coordinate point that works for quadrant 3, and we also found the value of x for which this is true. But we have to make sure we put a negative in front of it so that it is in the third quadrant. In the last little bit of this section, we're asked to find the terminal point of these angles. In the first one, we have 5 pi. if I were to keep track of the rotations for the terminal ray, I would have 1, 2, 3, 4, 5 pi. 5 pi is along the negative x-axis, with terminal point on the left side of the origin. That terminal point is the point -1, 0. So I rotated around 5 pi. I drew my terminal ray or terminal side, and then I extended it out to 1 unit, and then I found the coordinate point for that location. Let's take a look at B. Theta is -4 pi. That would mean we're going clockwise instead of counterclockwise. So 1 pi, 2 pi, 3 pi, 4 pi, and it's negative. So my terminal ray or side is along the positive x-axis, with terminal point at the coordinate 1, 0. Lastly, I have theta equals pi over 4. I know that pi over 2 is at 90 degrees, so pi over 4 would be 40 degrees. So my terminal side is in the first quadrant. My terminal point is at exactly the coordinate √2 over 2, comma √2 over 2.